I, Himapindu, along with my friends Apurva, Bhavani, and Rajni, did a project on reliable routing in wireless mesh networks using cross layer metrics under the esteemed guidance of Mrs. TNP Madhuri ma'am. Nowadays, the usage of mobile phones have been increasing rapidly, and so the transfer of information between mobiles and PCs has also been increased. But here comes a question about the reliability with which they are being transferred. So our project explains about the reliability and throughput with which the data is transferred. Dynamic routing algorithms are implemented in wireless mesh networks using cross-layer metrics to achieve reliability. This routing algorithm will make sure that the data takes most appropriate path to reach its destination. Before entering into the topic, let me explain you about the key terms involved. First of all, what is a network? A network is a communication link that allows computers to exchange data between them. Routing. Routing is a process of selecting the best paths in a network. Routing is performed for many, including telephone network, circuit switching, WMS, etc. A mesh network is a network topology in which each node relays data for the network. All mesh nodes cooperate in the distribution of data in the network. A mesh network topology. It is a decentralized design in which each node of the network connects at least two other nodes. WMN, Wireless Mesh Network. It is a communication network made up of radio nodes organized in a mesh topology. It is also a form of wireless ad hoc network. It consists of mesh clients, routers, and gateways. Radio nodes. The nodes which perform electromagnetic transmission are termed as radio nodes. Cross-layer matrix. It is a matrix which selects the best path with highest packet delivery. Now, I will explain about the overview of our project. Wireless mesh networks have emerged as a flexible and low-cost network infrastructure where heterogeneous mesh routers managed by different users collaborate to extend network coverage. Several routing protocols have been proposed to improve the packet delivery rate based on enhanced metrics that capture the wireless link quality. Expected forward counter and two further variants are proposed to cope up with the problem of selfish behavior of mesh routers in a WMN. EFW combines in a cross-layer fashion routing layer observations of forwarding behavior with MAC layer measurements of wireless link quality to select the most reliable and high-performance path. Implementation through NS2 simulator using ODSPR, that is On-Demand Secure Byzantine Resilient Protocol, and OLSR, Optimized Link State Routing, showed that cross-layer metrics accurately capture the path reliability and considerably increase the WMN performance even when a high percentage of network nodes misbehave. Few problems in the existing system are the problem of selfish behavior and the problem of selecting the performance path with more data traffic, resulting in less reliability. The solutions for the problems in the existing system are proposed in the new system. A novel routing metric, EFW, along with two further variants, minimum expected forward counter and joint expected forward counter. They are used to cope up with the problem of selfish behavior. EFW combines in a cross-layer fashion to determine routing layer observations and MAC layer measurements, which selects the most reliable and high-performance path. Now, let me show you the execution of our project. The tool used is MyEclipse 8.6, which is an IDE to show the simulation of our project, and the coding language used is Java Swing. Click on File and create a new Java project with some name. I am giving it as WMN20151 and click on Next. And now click on Finish. Now copy the source code and paste it into the created Java folder. This will overwrite all the source files. Now open WMN20151, that is the created folder. Click on source, click on default package. These three are the source codes which are used to show the simulation of our project. Source.java, router.java, destination.java. First run source.java. Next, router.java. Next, destination.java. This is the front end of source.java, this is the front end of router.java, and this is the front end of destination.java. Now, browse the text file to transfer it from source to destination. I created a text file in the mini project folder, so I'm opening it. Click on the existing system and say send. Now check out the router.java front end. There is selfish behavior at router K which does not send the information to all the other routers like router E, router G, router C, etc. Because there is a selfish behavior, that is, it drops the packets then and there due to data traffic, and the file is not received in the destination folder. Whereas in the proposal system there is a difference. To know this, click on the proposal system and click on send. Even though there is a selfish behavior at router E, the information is being transferred to router G because the selfish behavior at router F and router E is controlled by the metrics which we proposed in the proposal system, and because of this the file is received in the destination folder. Therefore, in the proposal system, though there is a selfish behavior like as we saw in router F and router E, the file can be received in the destination folder due to the metrics and due to the protocols we use. This is the action of our project. Hence, we would like to conclude our project by saying that the routing metrics proposed in recent years for wireless multi-hop networks fail to select the network paths with highest delivery rate in the presence of intermediate nodes whose forwarding behavior is driven by selfish interests. To overcome this problem, we propose a cross-layer routing metric EFW and two alternative refinements MEFW and JEFW to select the most reliable path by considering both the quality of wireless links and the forwarding behavior of network nodes. The proposed solutions considerably increase both the network throughput and fairness with respect to the baseline approach that takes into account only the successful transmission rate of a wireless link. We can therefore conclude that the proposed metrics and its refinements represent an effective solution for achieving high resilient routing and thus high delivery rates and in WNCNS. Cross-layer metrics accurately capture the path reliability and considerably increase the WN performance even when a high percentage of network nodes misbehave. Thank you.